Hello, Mr. Stoller here. So today we're going to attempt question 2 from Eastern Cape, September paper 1, 2022. Now, let's get to it. So, two blocks of masses 3 kg and 8 kg respectively are connected by means of a light inextensible string as shown in the diagram below. The string moves over a frictionless pulley and the 3 kg block is placed on a plane that is inclined at an angle of 30 degrees to the horizontal. A force of 55 Newton, which makes an angle of 15 degrees with the horizontal, is applied to the 8 kg block to move the system block to the right. The 3 kg block experience a constant frictional force of 5 Newton. The coefficient of kinetic friction between the 8 kg block and the surface is 0.16. So what I always encourage here when you are dealing with something like this, you need to indicate what is it, the forces that you are being told of there. So, like for example, here when you see what you call a block on an inclined plane, what you know is that okay, what I see here is that I'm gonna have two forces going down here, which is they already mentioned that there's friction there, so which is gonna be friction force. So it's kinetic friction here. Then there's another force that you know very well that on an inclined plane it's FG parallel. Okay, so you already have two forces going to the going down there. Then what do you have here? You have got a string here, what you call, and in a string, in a rope, what you see is tension. Okay, so tension is going there, it's always acting away from the block. Then again, what we also see is that they have mentioned what called okay, let's put the tension first, but they also mentioned something here that the coefficient of kinetic friction of block what called the 8 kg block. So it actually shows that there is friction here. There is what call also friction on the 8 kg block. Then now, when you look, when you see an applied force at an angle, what you know is that this force here is you're going to need what you call to resolve it. And when you resolve it and have the Fx, which is what you call the horizontal force, and also what you call the Fy. So what you see is that you have Fy going up and also Fx are going to the right because you are pulling at an angle. Once you pull at an angle, know that what call your force is going to be resolved. So that's what I see here when I look at this what call this force that we experience on each block. So it's just a quick what call what call, would I say, brainstorming, okay? Because you need this and you don't need what called to think of this when you ask the question. You just need to place the force that you think of whenever you see your diagram. Okay, so now let's get to it and see what we have today. State the Newton's second law of motion. We know this. We need to memorize the Newton's laws because if you don't memorize the Newton's laws, all these questions are going to start with the what called the law that they need you to explain. So Newton's second law, it says when a net force acts on an what called in an object, it will accelerate in the direction of motion. So it means that here, if we are what called, if we have this 55 Newton, it's our force. It's not net force as such, but the net force that we find here, we'll see that if it's to the right, that also is direction. Now, the other thing is that the acceleration is directly proportional to the force and inversely proportional to the mass. So it means that if you are to push something, what called, if we apply more force, it will accelerate what call quickly. But if you don't, if you accelerate, it will have more acceleration. But if we are applying what call the force on something that is heavy, we don't see much acceleration there. So what we see saying is that F net, this is the equation, F net is equal to ma. So we are saying acceleration is directly proportional to, so it means that here, if we are to have acceleration here, subject, it actually be what you call over m. So here, if we are to put the proportional sign, we see that acceleration is equals to, is a directly proportional to F net, but inversely proportional to mass. Okay, so the bigger the mass, the lower the acceleration. Now let's look at the next question that you're always being asked, which is the free board. So free board, what do we understand when we talk about free board? Free board diagram, you must have a dot. So let's go to 2.2. What is this saying? It's saying a free board diagram of all the forces acting on the 8 kg block. So when you look at the 8 kg block, we're going to say, all right, we have got our dot there, that's our representing our block, and any force that is what you call we are putting here is going to be F normal force. Then down here, what's going down here, it's our FG. Okay, you also see that sometimes you're seeing W weight there. Okay, so you can put FG or you can put weight, but you don't need to put both of them. Okay, now then here, what we are doing here, we are applying what we call, we have got also another force going up, which is our Fy. So it's gonna be Fy. So this is the Fy that we're talking about here. So it's acting on the 8 kg block and it's going up. And what about going to the right here? What we have is our Fx, and to the left, what we have is our what we call Fk. Then also have what is it? Our FG parallel. Okay, but you can also represent it in a different way. This what you call this what you call this free body diagram. You can say you put your Fn there. Fn is going up, but we are applying it in applied force here, which is at an angle, which is going to be 55. So you can just say, or you can put it as a Fi. That's applied there. Then we have got your Fg. Then what we have going there is our Fk, and also what did I say here? Can I just check here, change here, please? It's tension. Okay. Then you also have tension there. That's what you're seeing there. Okay, so you can take consider any of this graph. So you can, it's either you put this what call, or you put what call, you put this one. But all of them, they are actually correct. But what I encourage is this one here, because why? Because it have all, it include all the forces, resolved forces that you need to work with. Okay, so it shows you the horizontal force. It also shows you the vertical forces, all of them. But in this case here, we are just putting F applied, but it's not resolved. But now let's go on to question 2.3. Calculate the kinetic frictional force that the 8 kg block experiences. So what the hint here is that once you are given the coefficient of kinetic friction, just know that you will need to play around with this type of equation here. So the 2.3, which is Fk is equals to what we call mu Fn. You will need to play around with this equation because that's the one that uses the coefficient of kinetic friction. But now, do we have Fn? Do we have Fn? We need to resolve Fn and see what is our Fn there, because we are looking for kinetic frictional force, but we are given what is it? We are given mu, which is coefficient of friction. So the coefficient of friction is given there, 0.16. But what is not given here is our Fn. But now let's see how these are related. So what we know is that Fn plus Fy is equals to Fg, because these are vertical forces. These are vertical forces. So we're saying they are in equilibrium, but what the forces are going up is Fy and Fn. What is going down is Fg. So these are balancing. So we are saying what will be our Fn here? Our Fn will be equals to Fg minus our Fy. But what is Fy? Let's understand here. Fy is equals to F applied sine theta. What about Fx? But we don't need Fx here. Let's just put Fx here so that we know that it's F applied cos what we call theta. So I'm just doing this. It's unnecessary on the diagram there. But now let's now continue here and see what we can do. So we have got Fg. Our Fg is equals to mg. Our Fy is equals to Fi sine theta. So what we're going to do here is that going to be we substitute your Fn with Fg minus Fy. So let's now put it in. So it's going to be Fk is going to be equals to what we call mu in bracket mg minus what we call 55 sine theta. So this is going to be 0.16 in bracket there. What is our mg? Our mg is going to be equals to 8 times 9.8 minus 55 sine 15. Okay, what do we get then? Let's see, let's punch it and see what we get. So it's going to be 0.16 in bracket there. 8 times 9.8 minus 55 sine 15. Okay. So what we get is going to be 10.27. So here it's going to be 10.27 Newton. That's our Fk. So now we have got our Fk, which is 10.27. So let's move on to the next question. Now we are asked to calculate the tension in the string. Tension in the string, what call tension in the string and connecting the two blocks. So we are looking for the tension now. So let's just put those forces again. So we've got tension here. We've got tension. What is it? And what we also have here is it's our F K. And again here we have got FG parallel, and what we also have here is our FK. Then here we have got our FX. So these are the four that we're going to be dealing with here. So what you need to do whenever you ask the tension or acceleration, just know that you're going to come up with a simultaneous equation here. Okay, most cases you're going to come up with a simultaneous equation. Why am I saying that? Because here we've got tension here, because we can't just use what we call one diagram to find our tension, because they are moving together. Now let's look at the 3 kg block. 3 kg block. Now on the 3 kg block, what we are going to use here, we are using the equation F net is equals to MA. Now F net, what is our F net there on the 3 kg block? It's going to be T minus FG parallel minus FK, giving us MA. Okay, so I'm going to do also the 8 kg block here. 8 kg, when using the same thing, F net is equals to MA. What is our F net there? F net is going to be equals to Fx, okay, minus T minus Fk, which is going to give us our MA. Now let's substitute the value that we have here. So tension is going to be tension minus FG parallel is going to be equals to what we call mg, what we call sine theta. So mg is going to be times 9,8 sine 30 minus, what is our FK there? Our FK, will we give an FK? Yes, 3 kg block FK is 5. So it's going to be minus 5 is equals to, MA is going to be equals to 5, 3A there, sorry. That's our 3A there. So let's just try to find out what we get there. It's going to be 3,8 negative 3 times 9,8 sine 30 minus 5. What do we get? We get 19, negative 19,7. So it's going to be T here minus 19,7 is going to be equals to 3A. What about on the second slide here on the 8 kg? On the 8 kg, what we have, our fx is going to be equals to, remember fx is equal to 55 cos 15. So we're going to have 55 here cos 15 minus T minus FK here. Do we have FK? We have found it. It's going to be 10,27. But now let's just check here what we have. It was 10,2666. So we're just going to use 10,2 what call 666 just to be safe. It's going to be equals to what call our 8A. Now, what's going to be, what are we going to find here? Let's see, 55 cos 15 minus 10,2666. So let's just put it like this. It's going to be 42. It's going to be 42, 859 minus T is going to be equals to 8A. So always when you have got these two equations here, your tension is equal in the string. Again, tension is moving in the opposite direction because tension acts away from the block. So you find that here the direction of motion is going to the right. So it means that the tension here on the 8 kg block is negative, but the tension here is positive. So that will make them to cancel. So let's just write them, the two equations together here. So it's going to be T minus 19,7 is equals to 3A, our equation 1. Then it's going to be 42,859 minus T is going to be equals to our 8A. That's our equation 2. So what do you need to do here? You must add the 2. You must always add the 2 plus 2. Okay. Now, when we have this will cancel. This will cancel the tension. So when you cancel the tension, it means that you're going to have 42,859 minus 19,7, which is going to give you what we call 8 plus 3 is going to give you 11A. So what do we get as our acceleration there? We add the 2 there, we divide by 11. So here's going to be minus, let's just put minus here, 19,7. What do we get? Then let's divide this by 11. We're going to get 2,15. So it's going to be 2,105. Is it correct? Sorry. Yeah, 105. It goes on there. We can just leave it like that. But now, what do we need to do now is to substitute in one of the equation to find our tension. So we're going to say, to find the tension here, tension is going to be equals to, let's use equation 1. Tension is going to be equals to what we call 3 times 2,105 plus 19,7, which is going to give us, let's see here, let's say here times 3 plus 19,7 26,02. So it's going to be 26,02 newtons. Okay, that's how you get the answer. So always remember, guys, whenever you are having what called such kind of problem, that's what you need to do. In most cases, you also see diagrams like this where you're having a pulley, but you are having a block. Okay, you're having a block here, and that block, what called, it's connected again with a light inextensible string with a another hanging block there. So in this case again, you are actually applying the same thing. You're actually applying the same thing where you are going to have equation, our tension here is tension and also tension going up there. But what you see that if the block is sliding down, it means that the tension here is negative. So here it's going to be negative. This one here is going to be positive. So always these ones will cancel. So it's more like here you're having T minus Fk is equals to Ma, and here you're having there is Fg going down there. You'll be having Fg minus T equals to Ma. So the T and T will always cancel. Then you will find your acceleration first. Okay, so all the best, guys. Until next time.